Hello students, this is Ms. Dalton. I'm going to be talking about Notes 2-3, which is Solving Systems of Equations by Elimination. With elimination, you get rid of one of the variables by adding or subtracting equations. You may have to multiply one or both of the equations by a number to create variable terms that can be eliminated. So we'll see an example of that in just one moment. The steps for solving systems using elimination. So I've written out these steps to help you. Number one, you want to get both equations in standard form, ax plus by equals c, if it's not already in that form. And then number two, you're going to stack the equations on top of each other so that the like variables and the constants line up. Number three, you're going to check to see if one of the variable terms could be eliminated by adding the two equations. If not, then you're going to multiply one or both of the equations by a number to create a variable term that can be eliminated. Number four, you're going to add the two equations and solve for the non-eliminated variable. And then number five, you're going to plug your solution for that variable that you just found into either of the two original equations and solve for the other variable. Okay, so let's see how this works by working an example. Example 1, we want to first make sure that both equations are in standard form. So if you look at this, we've got our x's, then we have our y's, and then we have our equals and a constant. So it is in standard form, so we can go ahead and see if we can eliminate a variable. Step 2 says, let's see if we can eliminate the variable. So we're going to look at the x's. If I was to add those two x's together, I'd get 2x plus 4x, which equals 6x. So those wouldn't get canceled. If I have negative y plus y, when I add those together, it becomes 0, so those would cancel. So I'm good to go. I don't have to multiply through by anything, so let's go ahead and get started. So we're going to add these two together. 2x plus 4x is 6x. Those cancel, and we have it equal to 12. So divide by 6, because I want to get my x by itself. And that gives me x equals 2. So I can go ahead and start writing my point of intersect. The x value is 2. Now let's find the y value. I'm going to take this and I'm going to plug it in. Now you can plug it into either equation because this is a point that should work in both equations. But I'm going to plug it into this top one here. So I'm going to have 2 times the x value that you just found, which was 2, minus y, and I need to figure out what y value will make that equation equal to 0. So 2 times 2 is 4, minus y equals 0. So now I'm going to solve for y by subtracting 4. Then I have negative y equals negative 4. Now you have to divide by a negative 1 to solve that. And that gives you y equals a positive 4. So let's put that in my ordered pair over here. And now it's always a good thing to check your point to make sure that it works in both equations. It has to work in both equations for it to be a solution. So I'm going to do my check right here. I'm going to take the 2, 4 and plug it into the first equation. So I'm going to have 2 times my x value of 2 minus my y value, which is 4, and hopefully that's going to equal 0. So let's try it. 2 times 2 is 4, and 4 minus 4 does in fact equal 0, so that checks. Now let's check the bottom one. So my bottom equation is going to be 4 times my x value, which was 2, plus the y value, which was 4. And it needs to equal 12. So let's check. 4 times 2 is 8. And 8 plus 4 does equal 12. So it looks like it is a solution for both equations, and so therefore it is a solution for my system. Number 2, we have this standard equation, so we're going to do the system, and if you notice that the first step is to get it into standard form, and it appears that it is because here are my x values, then I have my y values, and then I have equals the constant. So it's already in standard form. So now let's go ahead and look at it and see if I add this together the way it is right now, would one of my variables cancel? Well, if you add 5x plus 4x, that's going to give you 9x. Then if you take a negative 3y minus 6y, that's going to give you negative 9y. It's not going to help me the way it is because I have to get one of these variables to cancel. Well, if you notice, look at your 5 and look at your 4. Now, I could go ahead and multiply both of those numbers times something to get them to cancel. And probably the best thing to do would be the 20, because 5 could go into 20 and 4 could go into 20, so I could change both of those numbers to a 20. But it might be a little bit easier if you look at your y values, because for my y values I have a negative 3 and I have a negative 6. So you can see that both of these numbers, if they were both a 6, then they would go ahead and cancel. So if I multiply this top equation by a 2, this is what I would get. So let's write it over here. 2 times 5x is 10x. 2 times negative 3y is negative 6y. And that equals, you also have to multiply this times 2. 2 times 18 is 36. Okay, now let's go ahead and write my bottom equation underneath it again. So 4x minus 6y equals 0. Okay, so now let's check it. 10x and 4x, we're going to just add those together. Negative 6y plus a negative 6y. Uh-oh, we've got a problem here. Negative 6y plus a negative 6y, that's not going to cancel. Now, I did this on purpose because I want you to notice that in order to get them to cancel, one of them has to be positive and one of them has to be negative. So let's go ahead and go back and let's change this top equation and let's multiply it by the negative 2. Because now when we multiply it by negative 2, we have a negative 10x and we have a positive 6y and we have a negative 36. Now we should be able to add them together and get those y values to cancel. So let's do that. Negative 10x plus 4x is negative 6x. 6y minus 6y, now they cancel, and it's equal to negative 36 plus 0, which is negative 36. Now, to solve for x, I'm going to divide both sides by negative 6, and so that gives me x equals positive 6. So let's write that in our ordered pair, 6, comma, and now let's plug this into either equation. It does not matter which equation you plug it into because essentially this point should work in both equations because it is a point of intersection. So let's just take this x equals 6. I'm going to plug it into the bottom equation because it just has some smaller numbers. So let's do that over here. So I'm going to have 4 times my 6 that I just found minus 6y, and that equals 0. So let's figure out what that would be. 4 times 6 is 24, minus 6y equals 0. Subtract 24 over to the other side, and you get negative 6y equals negative 24, and then divide by a negative 6, and you get y is equal to positive 4. So let's plug that into this point right here. This is what we think is our solution, but let's go ahead and check it. When I check it with equation number 1, I have 5 times 6 minus 3 times 4, and if I did it correctly, that should equal 18. Let's check it. 5 times 6 is 30, minus 3 times 4, that'd be minus 12. And that is, in fact, 18. So that checks. Now let's check it in number 2. 4 times 6 minus 6 times y, which was 4. And that should equal 0 if I did it correctly. 4 times 6 is 24, minus 6 times 4, which is 24, and that does equal 0. So it checks out, and this is my point of intersection, which is my solution to the system. Okay, looking at this next example, let's do step number 1, which is to get it into standard form, and let's check it. We've got our x's. Oh, but we've got a problem right here because we've got a y, but then we've got a constant. So it looks like this top equation is not in standard form, so we need to get that into standard form first. So I'm going to rewrite it over here. I need to take this negative 7y and I need to move it over. And this negative 15 needs to get moved over to this side. So let's do that. We're going to have 3x. When I take my negative 7y and move it over, it's going to be plus 7y. And that equals, move the negative over, that becomes a positive 15. Now on the bottom, it's in standard form already because I've got 5x plus 2y, and that equals negative 4. So now let's look at step 2. Step 2 says we need to get one of these variables to cancel. Now in this case, it looks like we're going to have to multiply the top and the bottom by some number because there's no way I can get 3 to be a 5 right here, and there's no way that I can get a 2 to be a 7. So it depends, whichever one you want to get to cancel, whichever one you think would be the easiest, you're going to have to multiply both equations by some number, and that number does not have to be the same. So if I'm looking at my x values right here, 3x and 5x, it looks like I could change both of those to a 15x by multiplying this one times 5 and this one times 3. Over here on my 7y and 2y, I could change both of those to a 14, and so whichever one you choose, it does not matter. I'm going to go ahead and make the x's cancel, so I'm going to multiply my top equation by a 5, and then I'm going to multiply my bottom equation by a 3. And if I do that, the top x's will be 15, the bottom x's will be 15, and the only other thing that I have to do is I have to make one of them negative. So let's just multiply the top equation by a negative 5, and that will get me a negative 15. So let's write it over here. What am I going to have? Negative 5 times 3x is negative 15x. And then negative 5 times 7y is a negative 35y. And then negative 5 times 15, that's going to equal a negative 75. Let's do the bottom one. 3 times 5x is a positive 15x. 3 times 2y is plus 6y. And then 3 times negative 4 is equal to negative 12. So let's go ahead and add those together. Negative 15x plus 15x cancels. Negative 35y plus 6y gives us a negative 29y. And that's going to equal negative 75 plus a negative 12 is negative 87. Divide both sides by negative 29. Okay, and y is going to equal positive 3. So if I write my ordered pair, remember your y value always goes second, so we're going to put the 3 in here. Now let's take this y equals 3. Always substitute it into the original equations. I'm going to substitute it into this bottom one. Don't try and substitute it into these equations right here because you might have made a mistake from here to here. So do it into the original equation, and that way if you made a mistake, you'll be able to catch it. So let's plug it into the bottom one. So I'm going to have 5x plus 2. Take your 3 and plug it in for the y. And that should equal negative 4. So what does what does x have to be to get that to equal negative 4? So 5x plus 6 equals negative 4. Subtract 6 from both sides. You get 5x equals a negative 10. And then divide both sides by 5. You get x equals negative 2. So that should go here. Now, do a check just to make sure. Let's take the top equation, 3 times your x value, negative 2, minus 15, and that should equal negative 7 times your y value, which is 3. Let's see if it does. 3 times negative 2 is negative 6, minus 15 equals negative 21. Does it? Yes, it does, so that checks. Okay, that was equation 1. Now let's try equation number 2. 5 times a negative 2 plus 2 times a 3 should equal negative 4 if it works. 5 times negative 2 is negative 10. 2 times 3 is 6. And negative 10 plus 6 is equal to negative 4. So yes, it checks. And here is my answer to the system. It's my solution, and it's also my point of intersection. Okay, on this last problem, I want you to pause the video, work it out on your own, and then press play when you're ready to check your answer. Okay, hopefully this is what you got for your answer. The point of intersection, the solution is 5,8, your 0.58. Okay, I just want to go over one more thing, and this is not on your notes for this lesson, but I just want you to remember that you could also have a solution of no solution, and that's when you have two parallel lines. But what is that going to look like when you're doing elimination? What it's going to look like is you're going to have, when you do your elimination, you're going to end up with something like this. So let's say my first equation is 2x plus 3y equals 8, and then my bottom equation is negative 2x minus 3y equals 10. Okay, so what's going to happen is when you add these two together, the 2x minus 2x is going to cancel, the 3y minus 3y is going to cancel. So I say that on the left side that equals 0, and on the right side it equals 18. So this is going to happen when your answer is no solution. Your x's and your y's will cancel, but your constants won't. And what I say is, if you end up with a false statement, like this statement right here, 0 is equal to 18. Well, this is a false statement, so when it is a false statement, your answer is no solution. Okay, so what's going to happen if your answer is infinite solutions? Well, what's going to happen there is everything is going to cancel. So an example of infinite solutions would be if you have the equation, let's say 2x plus 3y equals 8, but then the bottom equation would be negative 2x minus 3y equals a negative 8. Because what's going to happen here is your 2x minus 2x will cancel, 3y minus 3y will cancel, and 8 minus 8 will cancel. So you'll have 0 equals 0. And I say if you end up with a true statement, because that is a true statement, 0 does equal 0, then you're going to have infinite solutions. So what that means is those lines, this equation 1 and this equation 2, they end up being the exact same line. And that's why it's infinite solutions, because every point on that line is going to intersect, and there's going to be an infinite number of points that are the solutions. Okay, guys, don't forget, fill out your WISC document and submit it, and I will see you in class tomorrow.